Our next speaker is CTO at Dext. He has been doing software development since he was a little kid, but professionally he has over 20 years of experience. Over the years he has done a lot of things. He has taught Ruby at the university here in Sofia, which is amazing because he supported the Ruby community, so a little bit clap. He also has a podcast that he hasn't posted in about 6 years, I think. Yeah, well, I couldn't find it in Spotify. And he also recently started to stream in Twitch, so you can go and check this out. Yes, that's it.
And also he's my boss, so be very kind to him.
Well, thank you. Can you hear me? Let's set the record straight. I'm not Gennadi's boss. I'm the boss of Gennadi's boss. But I'm not here to talk about reporting clients. I'm here to talk about GraphQL. And what better way to start with everybody's favorite thing, audience participation. That's where I ask developers to move their arms. What fun. So, can you raise your hand if you've ever looked at the general direction of GraphQL? Okay, so keep your hand up there now. And continue keeping it if you've actually used it in some way. Okay, now keep it there if you've actually built or maintained the GraphQL API. Okay, and now continue keeping it if you think, transitions. If you think you're very good at doing that. Okay. No, I work with him. I know that's not correct. So yeah, that's kind of understandable. And it's understandable because GraphQL is like an onion. And bear with me. I've thought about this really hard. It's a very good metaphor. In fact, it's a threefold metaphor. The meaning of the onion is threefold, which means there are three. Anyway, you get it. The first way in GraphQL is like an onion, is that it can be really enjoyable if you're into onion. There's quite a lot of good Indian cuisine with onion. It can be quite tasty. Also, it has layers. I don't know how many times I thought I finally understood GraphQL, and then I peeled a layer, and then more onion. And finally, most notoriously, it can make you cry. So my goal today is essentially to give you a taste of the French onion soup of GraphQL. And give you some tips on how to make it nice. And by the way, Yaroslav here. I made this image with ChatGPT, so yay, my job is safe. I'm Stefan. Here's how I look in the internet. Here's how I look in real life as well. You can find me here in various things. Now there's a bit of a good news and a bit of bad news. The bad news is that everything here is in Bulgarian. The good news is that I've not posted in any of those things for ages, so you're not missing out on anything. In fact, speaking of YouTube, the last video I tried to make was on Haskell, but I was too lazy to finish it. You're not supposed to laugh or clap, because if you didn't like this joke, you're really gonna hate the next one. Anyway, I have been, using GraphQL since 2016, pretty much kind of when it came out a bit later than that. And first I want to start with my angle on GraphQL, because how I'm using it, because there are many different ways in which one can use it. So first, I'm working on an information system with a complicated model. We're showing a lot of data, we're letting the user edit a lot of that data, and there are way too many tables in there. Some of those tables are small log tables or something, but it's still too many tables. And that's important because if you're doing something much simpler, your experience is going to be different. We're also fetching all the data through PostgreSQL. That's compared to, using GraphQL to fetch stuff from other APIs and service it in the same request. That's a different problem with different interesting challenges, but it's not the problem I've got. We also add GraphQL much later over like a bunch of legacy code or existing code, depending on how generous you want to be. And that's important because if you start a new project today with GraphQL, you could write Ruby in a way to avoid some of the pitfalls. But then again, if you have like a lot of Ruby code, you need to figure out how to make it work. And finally, we have a React client that uses this API, an iOS client, and an Android client. Those are 3 separate code bases doing 3 slightly different things. Because if you're not in that situation, why are you using GraphQL in the first place? You could use Hotwire. I really like Hotwire. Or you can even use the React Server components. I also really like React Server components. But anyway, with the transitions. Speaking of GraphQL, the story is very different on the client and on the server. And I like an entire talk on GraphQL on the server, but on the client, but usually you're gonna do this in Swift, in JavaScript, in Kotlin. So what you're gonna do in Ruby is the server, and I'm just gonna focus on the server. And for those of you who have not seen GraphQL, let me make a super quick introduction. So it's a way to do APIs, and you're doing it instead of REST. But it's still over HTTP, and the responses are still JSON. Now, I know you don't need to do REST with JSON, but like everybody does REST in JSON, so in that way, they're similar. You also don't need to do GraphQL or HTTP, but like everybody does it, so close enough. This is the same. Where it's different is when you make a request. Here, you use a custom language. It has its own grammar. It's whole thing. You expose it by having only a single endpoint, and you only post to that endpoint, kind of like we did code in the 90s. You specify what you want to get back, and you get back only the stuff you specify. And finally, the structure of the API is a bit kind of strongly typed. And by that, I don't mean if you want to consume it from JavaScript, you need to like generate a bunch of stuff like protobufs and such nonsense. You can you get a JSON and do a bunch of stuff with it. But if you're writing in TypeScript or in Swift, you could actually generate some types for your API responses. Now, GraphQL is made out of 3 things, essentially. Queries, where all the fancy stuff is. That's where you fetch data. You also have mutations, but that's essentially remote procedure calls, and then you can do a query on the result. So it's not that interesting. And subscription, which is kind of server-sent events, but you can also make a query. So really, the only interesting thing in GraphQL are the queries. That's where the complexity is, and that's what I'm going to focus on. And I need to show you some examples. So I'm going to show you some examples from the GitHub API, or rather, they're going to feel a bit GitHub-y, because they API. Every time I wonder how to do something, I go to their API, and usually the answer is do it like how they've done it. But if I showed you real GraphQL request to GitHub, it's going to introduce a bit of complexity that we don't need for this narrative. We can circle back to it later. So it's going to be GitHub-ish. And here's a GraphQL request. It's kind of very similar to the first GraphQL request I ever wrote. We are fetching a pull request, and we know that the pull request ID is 1. And we want to get the ID, the title, but we also want to get all the comments of that pull request. And for each comment, we want to get the body and some information about the user who made it. And we also want to get the repository name. Now, when you fire this request to the GraphQL API, you get back a JSON. And the structure of that JSON follows closely the structure of the request you're making. You can see that here's the pull request, here's the ID, here's the title, here are the comments in an array, here are the users in those comments, here's the repository. You kind of get the idea. And importantly, if you don't select all those fields, for example, if you drop those fields, you get like a smaller response back. So you only get what you select. Now, how do we implement something like that in Rails? First, First, we start with a active record model, which is something like that. Could be something like that. Fairly straightforward. We have a user, we have a comment, we have a pull request, we have a repository. There are a few associations. you know what they mean, you've used GitHub. So that's where we start. Then we need to add the GraphQL gem, which is what's going to help you building an API. I have a lot of things to say about that gem. It was really horrible 7 years ago. It's actually really great today, but it's still very far from the smoothness of Rails. It could be way more Railsy. It's not there, but it has massively improved and makes life much easier. The first thing you're going to do there is you are going to define your query type, which is the entry point, what you can start your request with. Here we are defining the field pull request. It's going to take an ID. It's going to return a pull request type, which we're going to look in a bit. And when the user selects this field, we want to execute this Ruby code to fetch the data for it. We call those resolvers. And this is basically what we need to implement this part of the query. Now, when we move to the pull request type, which is going to give part of the query, the story is kind of similar. It's going to get instantiated with pull requests, the active record object returned in the previous one. And here we have those fields, ID and title. They're just methods on active record. We don't need to do anything about them. Those ones are associations. Honestly, we don't need to do anything about them either, but we can also write resolvers like this. And here I'm just using the active record associations. And I'm actually going to not use the associations for a while, and I'm going to do them like this. I'm going to pretend active record associations don't exist. Just again, because it makes the narrative easier. So when we want to fetch all the comments, we need to select all the comments with this pull request. We should probably order them or something so we get stable order. And we want to select the repository. We could do it like this. Storing the comment type is similar. Fields are on the comments. For the user, we're doing a user find here on the user ID. And this is this part here, not the body, but yeah, you get it. Sorry, the body as well. Here's the body. And finally, the user type for completeness. Here's where you get the pull requests. Now, as I mentioned, all of this is kind of typed. So you would have a thing called the GraphQL schema that describes all the types. Your entry point, which is the query, and then all the different types you can get from the query. You don't need to write that. GraphQL Ruby will generate this for you, which is really nice from your Ruby code. But it's there, and the client is going to need it. So at this stage, you may be wondering, why is it actually called GraphQL? And if we draw the schema this way, we can actually see it. It's, a graph. I know it sounds like very computer science and stuff, but yeah, there's the graph. All the types are the nodes, and then all the resolvers are edges between the nodes. You could think about that every object is the node, but anyway, details. Close enough. So at this stage, you're going to be okay, but where are the tiers? I promised you tiers. Well, let's see how one of those things gets resolved. So, and here's the query. And let's see what will happen when we run that query with the code we've just written. Execution is going to come here. And now we need to make a query to the database this time. It's straightforward query. You know how it works. It gets the pull request by ID. Then we go to the comments and we select all comments with that pull request. That's fine. Then we get into this user. Well, we have a comment. It has a user ID. So we run this query. Then we go to the next user. And we run this query because it's a different user. Then we go to this user. And again, we run one more query. And just for completeness, let's run one more. And it's actually the first one again, but whatever. We've now made 4 queries before continuing. And yeah, you'll see the problem is an n+1 here. Now, we don't want to do that, obviously. We want to do something else. Instead, we want to do this. That's what we've done in Rails for ages. And I know what you're going to say. Why don't we use includes or preload, which I think is a bit new? Well, sure, but where do we put it? If we go back to this comment type, we don't have an array of comments. Here we just have a single comment. It's already loaded, and we need to find the user. So We cannot like really preload here. And where we were fetching the pull request, we don't really know whether we've selected comments or not, so But then another more subtle problem we've got is that when execution reaches here, we need to resolve this field before we move on to this field. And at this stage, we need to like say, here's what you need to do for this user, without actually coming here and knowing that we have other users or something else that's going to get selected. So that's kind of why the most straightforward approach, even with associations, wouldn't work. It gets a bit complicated, and I know what you're thinking. We have a problem. It's a complicated problem. There's graph in there. It's computer sciencey. I know what to do. I'm going to use Haskell. And you're going to be right. Or partially. We could do just like the lazy thing that Haskell is famous for. And here's how it's going to look like. We still have the same execution process. We start here. We make this query. We make this query. But when we come here, instead of returning a result, we're saying, you know what? I know I need to fetch a user with an ID 1, but go away and come back to me later. And then we repeat the same process like a few more times, once for each comment. And this way, we've like told GraphQL, or rather the gem, that like, yeah, okay, I'm gonna need to do something here later. And we've had an opportunity to collect all the IDs we need. And then we can continue with resolution. And now, once everything is complete, we do a second pass. And we go and say, okay, let's fetch all those things together. And now we can actually run the query we wanted to run in the first place, where we just select once from users and we don't select the same user twice. Now, how do you do it? There are two ways. GraphQL has this thing called lazy resolve, which you could use to build it yourself. Or there's a gem from Shopify called GraphQL Batch that you could use that's going to kind of do it for you. Now, I don't use GraphQL Batch. I don't think you should be using GraphQL Batch. I don't think Shopify should be using GraphQL Batch. I really do not like GraphQL Batch. But I'm going to show you examples with it anyway, because that's what everybody's doing. And there's a big asterisk here, something called GraphQL Data Loader that I'm going to like put here, park it for a while, and return to it, and now pretend it's not going to exist, but remember that asterisk. So after we've installed the gem, instead of doing this finder here, we could actually do this. I would love to say that GraphQL Batch gives you this record loader, but it actually doesn't. It gives you the tools to build one, which is one of the many reasons I don't think it should exist. But that's how you can do it. And if you've copied this record loader from GraphQL Batch in your code and install GraphQL Batch, you're going to get this execution plan. And let me just show it to you again. Instead of doing a user find, we're like building a record loader for the user class, and then we're saying load this user with that ID. Cool. Now, problem kind of seems solved. So why am I talking about this? Well, it's because not just finds. We often want to do more, and we actually want to use those associations. Here's some Ruby code again. Here's the active record class for comments, but now we've added two methods. And I think a book can be written about whether this is a good idea or a bad idea, and like when it's a good idea and when it's a bad idea, but you see code like this all the time. And what's interesting here is that you have like a higher level method called name that like goes and reaches for another association to do something with it. In this case, it just proxies the username. But you can have like a more complicated one. Now, this returns a pointless string, but the pattern is there. You see that in a lot of production code, where in order to calculate the comment summary, we need to have the username and we need to have the pull request title. And again, the challenge with those methods is that if you run them into a loop, you need to make sure that user and pull requests are loaded on the comments you're looping over, otherwise you get n+1. Now, Rails did introduce a way to slap you when that happens, and it has had a way to preload those things for ages. But again, we don't have that in GraphQL yet very nicely. But anyway, let's see how we can implement one of those in GraphQL. And also like avoid n+1s. Here's the author name, and I'm just going to inline it here so it's easier to follow. It could be object.authorName, doesn't matter. Now, if we just do this, it's not going to work. It's going to introduce an n+1 because every time we reach to this method, we're going to do a select from user. Now, since you're using the gem from Shopify, you could try doing this. It kind of worked here, so should work here. Well, it doesn't. And it doesn't because record loader doesn't return a user. It returns a promise. And the air quotes are very deserved. Again, I really don't like this gem. So you cannot really call name on it. You actually need to do something like this. You need to like call .then and then do stuff with the user. And for the other one, you could, in theory, do it like this, which is a big mess. Now, it doesn't need to be a big mess. You could wrap this behind some helpers that you call, and it's a bit shorter. And it's going to be kind of OK then, but it's not always going to work. And it's not always going to work because the minute you start nesting resolvers, it doesn't always prevent n+1. Now, there's detail to go into why, but just doesn't always work. But you could still do it. Now, so far I've not been using associations, but if we needed to have those methods in comment, we're going to need to do it through association. So that's like trivial enough to do with GraphQL batch. Instead of record loader, you're using something called association loader, which is kind of the same idea, but instead of running a query, it like loads the relation on that object, which would run the query and then like store it in the parent, so it's there and you can use it. And again, that's a bit better. You could wrap this behind some helpers. It could be a bit nicer. It's still not going to always work for nested stuff. And that's kind of the state of the art. Or it used to be the state of the art, because let's return back to this asterisk. I didn't go into details. So GraphQL introduced something called the data loader. And the data loader, is it here? The data loader. The data loader was a great way to do a bunch of things like batch your network requests in order to fetch your responses from some other API you're hiding behind GraphQL. But just last week, right in time for this presentation, they introduced those two methods, data load record and data load association, which kind of improved the situation. And if you only use them, you use them like this. So you could use either, and they're like kind of what we did back then with GraphQL batch. You could just like do a find here with this one, and you could do data load association, which would load association, still do a find underneath, but yeah. And it's going to solve the n+1 for you, because there's some code written behind it. As for our two methods, we could even do it like that. Both of those would work. The first one calls data load association to get the user, and then calls name on that user. The second one just calls it for the side effect of loading that user, and then uses the method on active record. And by now you're thinking, wait a minute, why does this work? We need to do all this nonsense with like promises. With GraphQL batch, it was like this really weird syntax where we need to do the horrible JavaScripting before syncing await. Why would this work? And the answer is, of course, fibers. Has anybody used fibers? Okay, so maybe I should explain what fibers are. So fibers, some people would say they are like threads, but lightweight. Other people would say they're nothing like threads. Both of them would be correct depending on what they mean. They're kind of like a generator function, or they're used kind of like a generator function in this particular case. Generator functions are the things in Python or in JavaScript where you could actually suspend the function. So normally, when you have a method like this in Ruby, you run it, and then you wait until it completes, and that's it. It can go and call some other methods, but essentially you need to wait for it until it finishes, and then it's done. With generator functions or with fibers, you can get a behavior where you call this method, and it decides to reach a point where it just wants to stop and give control back to you. Then you can go do other stuff, and then you can resume it later. So what would happen is on the first pass, we would get to here. That method is going to get suspended. We're going to go do a bunch of other stuff. And then when we've done all the other stuff, when we've collected all the IDs we need to fetch, we're going to resume those methods to get the actual result. So on the second pass, this code is going to get executed. It's actually even a bit fancier. I'm quite impressed. I would have thought of that idea, but the way they do it is that they run the whole GraphQL execution in a single fiber. And if you're never using a data loader or anything, it just finishes in that fiber and that's it. But if there's a data loader there, this fiber suspends. So now they start another fiber, which they use to continue execution. And if that one suspends, they start another fiber. It's all a bunch of fibers. And then they finally get all the results together, which is why you don't see a yield in this code or an await in this code. Kind of feels like coroutines in Kotlin or whatever they were called. So going back to the comment, you can do you can call data load association on the object to get the user first, and then the pull request, and then you can call your method. Now, I haven't tested this, but this is kind of nested, so it may suffer from the problem of nested laziness. Doesn't always work. You could do it like this. Now, this API is a bit messy, but that's just because GraphQL Ruby has not wrapped it up in a nicer one, where you split the data load processing of requesting here saying here that you're going to need those things, and they're not going to suspend. Execution is going to continue, and then the load here is going to suspend. But at this stage, the runtime knows you're going to need both of them, so it can fetch them together. And yeah, that's how you can do it these days. It's much better, but it's still much harder than it should be. You need to use a very showy framework called Promise with GraphQL batch. Here you can use this, but you need to use fibers. And when you start using fibers, you won't see it until you have exceptions. And then when you get an exception, your stack trace is going to be really weird. And I don't think it needs to be that hard. So join me in trying to imagine what a better solution would be. Close your eyes and think, or don't close your eyes, whatever works for you. And again, I know what you're thinking. We're going to use Haskell. But anyway, no, seriously, can we do better? And here's a thought experiment. If I show you this query, do you know what do you need to promote where without fibers and promises and all nonsense? Well, yes, you do. Not only you do, but Rails has had this for ages. You're getting the pull requests, and you want to preload all the comments. Okay, slightly different, whatever, you get the idea. And this has always been there, so we know how to do it. And just looking at the query, we can figure this out by thinking. We don't even need to use AI for that. And of course, if the query is different, we load different things. In this case, we've added the user, I think. So hypothetically, it could work because Rails already is capable of doing all this work for us. We just need to figure out how to code this and where to code this. And by the way, it gets better. We don't even need to figure out how to code this. Rails has this slightly private API where you don't need to have the preload where you do the selection from the database. You could select the objects, instantiate them, and then you can preload associations later. So you can separate those two. And it gets even better because this private API has this available records parameter where you can give it some records you've already seen. And that way, if the repository user is the same as one of the users in the comments, it will not even like go and select it again. It is going to know that he's seen it and just going to use the same object, which is going to have the nice effect of setting all your association in, this time, your active record graph. So Rails provides everything for us here. The only thing we need to figure out how to do is actually build this weird object that contains 2 symbols and a hash. I know that only Božidar here understands this weird syntax because he had to deal with it in Rubocop. Anyway, maybe somebody else does. So how can we do this? Well, we could annotate our GraphQL types. We could say the comments are an association, and every time we select some comments, let's go and recursively see what we're selecting on those comments and preload associations there. This doesn't exist in GraphQL, I'm just making stuff up. Or we could do it like this. This syntax really freaks out everybody. Ruby doesn't have decorator. I think this is a decorator, kind of like rake tasks. If it doesn't make sense, don't worry about it. The whole point is you can specify that like here, this is going to return this association. When it's a string like our methods, we could like do this. We say, well, in order to like resolve this field, on this comment, I want to have the user preloaded, the pull request preloaded. Let's throw in the repository for good measure. Or we can like put it even here if you want. Again, those things don't exist yet, but you could do them. And now when you have this whole metadata on your GraphQL types, every time you start resolving a request, you could figure this one out, and then Rails does everything for you. I think this is going to be a much better solution. So the resolvers are just declare the active relation they model, or the dependencies they have. The dependency graph is known in advance. You don't have fibers, you don't have lazy execution, you don't have promise RB. It's gonna avoid selecting record twice, and it could even avoid selecting from the same table twice, although, again, that one depends. I really don't understand why this is not in GraphQL, in the GraphQL gem, because it's just like 250 lines of code, and I know because that's how we've done it. Now, I would love to open source it, but you know, I have only one project where I could use it, so I would struggle to make a good thing out of it. But if any of you has this problem, drop me a line. I would be happy to show you how we've implemented that, and maybe we can do some open source together. But more importantly, I just want to encourage you to, on one hand, if you have this problem, solve it this way, or at least try solving it this way. And more generally, when you face problems where the tools are annoying, do stuff like this in order to see whether you could solve them better. All right, finally. And this is going to be a quick one. I showed you how it works on the belongs to side. Let me show you how it works on the has many side. Now, this is actually the first query I wrote in GraphQL in 2016. I want to get a repository, and for that repository, I want to get all the pull requests, and for those pull requests, I want to get the comments. Because I was like writing a tool to see if Gennady has commented on all the pull requests he needs to comment on. And here is how execution could work here. We again select the repository, we go to the pull requests, we select the pull requests, and then for each pull request, we come here and select all the comments for that pull request. We order them by ID to get a stable order. Then we do it for the second pull request, and then we do it for the third pull request. And again, this is an n+1. And again, we know how to solve this. Instead of doing this query, we could do this query. It's going to give us all the pull requests in all the, all the comments in those pull requests. It's even going to give them to us in the right order. And it's just like a matter of then taking this array and splitting it on pull request ID. And then we have like 3 different arrays for each different array of comments. We don't even need to do that. Data load association is going to do it for us. That's not where this is tricky. Where is this tricky? Because you don't want to get all the comments. You want to get the first 10 comments maybe. Actually, you can't get all the comments in GitHub. If something in GitHub has too many comments, you're forced to page. So you're only going to get the first page. And there's a limit on how many things you can get on that first page. You can specify this number, but if you specify anything more than like 500 or something, GitHub says, or 100, GitHub says no. So the actual execution plan looks like this. And the really big difference here is this limit. Because now here, think about how you can avoid doing those 3 separate queries and do one instead. Now, you could try doing this. And this will indeed fetch all the comments in all those pull requests. And then you can group them, and then you can slice them. And you're going to end up returning 10 pull requests per repository. But you end up loading more than 30 comments in memory, and you end up doing all this traffic from the database that's going to slow you down. You could try doing this, where you have this limit here. That's completely not going to work, because you have no guarantee that you're going to get 10 comments from each pull request. Like all the recent pull comments could easily be in pull request 1. So you're going to get 30 from there, and that's it. So can this be done at all? Okay, how? Not specific enough, but okay. Sorry? No, it won't work. You need to do paging, and then you need to do few. Yeah, won't work with just distinct on anymore.
Postgres has some overrides called, it doesn't do a subquery, but it does another query from the big query.
Okay, yeah. Let me stop bothering you. PostgreSQL is actually having a feature that's called windowed queries, where it would allow you to group the different pull requests in different groups and the different comments. Sorry, and then like apply an order in each group, and then only limit each group to 30. Even that is too complicated because PostgreSQL has something called a lateral join. Now, the reason I'm showing this to you is because I didn't know about this. And when I found about this, I was like, cool, this is awesome. So if you have one thing to take away from here, is like, go look at lateral join. The query looks like this, where here inside you have the query that like selects all the comments from this pull request, limits to 10, and orders on create that. But it's within another query, which I guess is technically a subquery, but you also need the lateral join, so it's not just subqueries. Where you say, I'm going to need like the pull request with those IDs. Interestingly enough, you don't even need to select anything else from pull request, so this table here doesn't need to be pull request, it could be anything, doesn't really matter. And then if you want to use it in Rails, you could do it like this. And if you find this code confusing, don't worry, I also find it very confusing and I wrote it. I actually had to understand what it does before I put it here. That's not important. The important thing is that there is a way to solve this, which we're also doing. Anyway, let's wrap up. Now, so far, I've been avoiding the really big question, which is, should I use GraphQL? I've been telling you about how we're using GraphQL and some of the challenges, but I never told you whether you should. And of course, I'm going to give you the most boring answer in the world. It depends on what you're doing. It makes like perfect sense for our use case. I'm very happy we went there, actually. There are a lot of things I won't do with GraphQL. There are a lot of things I wouldn't even do with React. I would do with Hotwire. It really, 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 really depends on what you're doing. There are some very good use cases, and there are some areas where it's just too much work. But more importantly, it really depends on whether you like onion soup. Because the moment you start working on a more complicated GraphQL API, you run into problems like that. And they require, like, it work to solve them. And honestly, it took me like years before I got to the idea of let's just use preload, Don't know why. Maybe I could be a better programmer. Maybe AI can help me. Maybe Yaroslav's courses can help me. But yeah, anyway. So yeah, it's also about the onion soup is what I'm trying to point out here. If you enjoy that kind of stuff and like extending the library you're using, You could find a lot of joy there. If you don't, you better have a colleague that does, otherwise you're gonna suffer. And if I if I need to keep this really, really short and summarize it in one word, it's going to be Haskell. No, never mind. Anyway, that's it. Thank you and bye.